Hello beautiful people and welcome. In this video we're going to be working on some examples of graphing cubic functions. Now if you haven't already watched the introductory video, go ahead and watch that as we're just going to jump into doing these, what are we doing? Examples. We're just going to jump in to do these examples. As always, if I make a mistake, let me know where it is so that way we both can learn from my mistakes and you don't have to make your own. All right, so the very first one, I wanted to go through this specific example because of the horizontal change that we're going to have. Remember, if it's inside the bubble, here's your bubble. Let me make that bubble bigger. And this is the bubble because all of that, the bubble is being cubed. Therefore, we know that it's going to be a cubic function. This is inside the bubble. We have a 2 that is inside the bubble. We also have a plus 3 that's inside the bubble. Now, outside the bubble, we have a plus 4, so we need to account for that as well. The 3 right here, this 3, simply tells us that our function is cubic and that it's going to look like Mr. John Travolta. So the parent looks like a Mr. John Travolta. Again, if you don't know that reference, that is in regards to him dancing. If you're in my class, you're going to be able to see that clip during class time. So this is what we call Mr. John Travolta because when he dances, he does this. That's when he dances. If you don't know, just Google John Travolta dancing and you'll be able to see this shape. All right, so inside the bubble is a 2. Whatever we have inside the bubble, we're actually going to do the opposite. So if we have times 2 here, we're actually going to divide by 2 or multiply by 1/2. I don't know if you guys can hear the helicopter going. It looks like it's right above us right now. I apologize. Again, so we're doing the opposite. If it's inside the bubble, we're doing the opposite. We see a times 2, 2 times right here. So we're doing the opposite. We're going to divide by 2, or in this case, multiply by 1/2. Same thing. Here we have a plus 3. We're doing the opposite. We're going to do minus 3, or we're going to go to the left, 3. Here is outside the bubble. Outside the bubble is exactly what it is, plus 4, which means we're going up 4. This outside the bubble means vertical change. Inside the bubble means horizontal. So this times 1/2, what that means, it's a horizontal compression. Means it's getting smaller. Okay, so now that we have that, let's go ahead and start graphing. Let's start out with our parent function. Our parent function is f of x is equal to x cubed. We want our pretty points or our reference points for our function. And in this case, we have 1, 1, 0, 0, negative 1, negative 1. You should start remembering these for the cubic function. These should be in your memory by now. Now, what are we doing? We're going to be graphing the transformation. We're graphing things happen to these points. What happens to these points? Well, first of all, we have a horizontal compression. So we're going to multiply something by 1/2. Now we're going to shift left 3 jumps. We're going to go up 4 jumps. So now we have to determine which one's going to be the horizontal, which one's going to be the vertical. Now, horizontal is left or right. And then your vertical is your up and down. Or your horizontal is your x-axis and your vertical is your y-axis. So when we determine our new points, we gotta determine what our new x and y are gonna be. Oh, you guys can't see that. Let me change that to a marker so you guys can see that a little bit better. So here is our x, or horizontal. Here's our vertical. So something's going to happen to our x. So here's our x, and something's happening to it. And here's our y, and something's happening to it. So what is happening to our horizontal? So for a horizontal, we have a horizontal compression. So we're going to be multiplying this by 1/2. I should probably not use that color if I'm trying to color code. Then we are going left 3. Left, again, is that way. That means it is horizontal as well. So left 3 means we're going to the opposite. So if I see a plus 3, I'm doing the opposite, which is a minus 3. Vertical, the only thing vertical I have is an up 4. So that means it's outside the bubble. So if I see a plus 4, I'm going to do a plus 4. And these two things are equal to my new pretty points or my new reference points. And this is my y2. This is my x2. So what am I doing? I'm doing the equation that I just developed based on my transformation, and I'm going to plug in my reference points, my x and my reference y. So inside here goes my reference point. So I have 1, 0, negative 1 as my x. So 1, 0, negative 1 as my x. And then what do I have for our y's? For the y's, I have 1, 0, negative 1, 1, 0, negative 1. So now I'm going to solve what these are equal to and then graph on the plane. So we have half of 1 is half. Half minus 3. So all we need to do is, what do we have? Ooh, do you guys see that? So I have half minus 3, so that's negative 2 and 1/2. If you want to do decimals, that's fine, but fractions are your friends and they want to be loved as well. So this is half minus, oh, this is not half. I almost made a big mistake. Half times 0, 1/2 times 0 is 0, so I have negative 3. And then here I have negative 1 times half, so that's negative, so I have negative 3.5. Let's look at our y's. Oh, you guys, this should be a 4, not a y. That's a 4. 4 plus 1, I can do that. That's 5. This is 4, and this is 3. Okay, so let's go ahead and graph it. So what do we have? The reason we did this is to create points. So my new x is negative 2 and 1/2. My new y is 5. My new x is negative 3. My new y is 4. My new x is negative 3 and 1/2. And my new y is 3. And I'm going to show you the other way, how to plug in pretty points and why we have these values here. All right, so let's go ahead and graph that. So I have weird looking things in my x. I'm going to make these a little bit bigger. Oh, I have a 5. So 1, 2, 3, 4, 5. Let's make this even bigger. All right, 2, negative 2 and 1/2. 2 and 1/2 is about here-ish. And then I have 5, so I'm going all the way up. Let's change markers so we can see the difference. 1, 2, 3, 4, 5, 2.5. That's about here. Then we have negative 3, and negative 3 is a 4. Oh, you guys. It's okay. Let me actually graph it somewhere else because my letters are right in where it needs to be. Okay. So let's go ahead and try this again. I have negative 2.5 and 5. I have negative 3 and 4. And I have 3.5 and 3. So here are my 3 dots. Again, this is not a linear function. This is a cubic function, which means that I'm going to have my vertex, which is going to be this point here. And from the vertex, I'm going to go down and then go up. Because we did not have a negative out in front, if we had a negative, then we would reverse that. Actually, let's do that as our next example. Throw in a negative. Okay. And here you have it. Now, let's do this one more time using our pretty points and our function. So if we wanted to do it this way, let's put this in a thinking bubble. Oops, sorry about that. My function is, what is my function? My function is g of x is equal to 2x plus 3, and then all of that is being cubed plus 4. So the pretty points is, what do we need to put in there to make things, pretty? So let's see. My vertex, trying to figure out a good color, my vertex is h comma k. So if I was to do this, this is x minus h, and this is plus k right here. So h is whatever the opposite that you see. So for example, I see plus 3. So my h is going to be minus 3. And my k is exactly what it is, so it is 4. Excuse me, guys, for just 1 second. I don't know if you hear that, but there's a lot of noise outside. Let me close the door. Hold on. All right, and we're back. Okay, so the vertex is h comma k. So whatever you see here, you're going to do the opposite. So if this is plus 3, your h is going to be minus 3. K is outside the bubble, so we're not doing the opposite of something that's outside the bubble. Only opposite if it's inside the main bubble. So here's a plus 4. We're going to do plus 4, so we know that that is our vertex. So here it is, negative 3, positive 4, and we can see that our vertex matches up. So from there, we have to choose something that's bigger and something that's smaller. So keep in mind this is a negative. Now I can do whatever I want. You know, I can do a 0, I can do a 1, I can do whatever I want. However, you want something that's close to the vertex. And I'm thinking, if I wanted to do 1, I can do 1. If I wanted to do negative 1. So if we do negative 1, let's see, I want to do numbers that don't necessarily match up there. So if I wanted to plug in 1, let's see what we have. We would have 2 times, let's do negative 1 because I want it smaller. Negative 1 plus 3, that's all cubed, plus 4. I have a hunch that this is going to be a very big number, or at least a bigger number than what I can fit here. So 2 times 2 cubed plus 4. 2 times 2 is 4. We want 4 cubed plus 4. 4 times 4 is 16. 16 times 4, I believe that's 64. That is. So I have 64. Now 64 I cannot graph in here. So just going to negative 1 is already too big for us. So we need to cut back. So I'm going to cut back to something again that's pretty. Here's a continuation of our thinking bubble. So I want to cut back to something that will give me a pretty number. So the reason we have a reference point of the x value being a fraction is because I have a fraction here. I have a multiplied by 2. So if I do, oh, I don't know, let's convert this. Let's do negative 2 and 1/2 plus 3 cubed plus 4. I'm going to convert this to an improper fraction. So I have negative 5/2 plus 3 cubed. This is why we have a fraction. You can see I have a times 2 and I have a divided by 2. Those two things get crossed out. Alright guys, so I went back and I caught my mistake, so I went ahead and erased it. If you can go ahead and erase this as well. And I'm going to show you what I did wrong and by doing it correctly this time. So originally what I did is I converted this to an improper fraction and then I simplified. What I didn't do is realize that this is distribution. Right? We could also combine the insides. So that's what I did wrong, is I didn't multiply 2 by the entire bubble. So what I really have is I have 2 times, I'm still going to convert to an improper, but I have times 3. All of that's being cubed, added to 4. Now, inside the bubble, I can do two things. I can either distribute and then add, or I'm going to combine inside. If we do PEMDAS, PEMDAS says, please excuse my dear Aunt Sally, so parentheses come first. So that means I would do this. However, you are in Integrated Math 3, and so you can choose to distribute, just like you would if there was a variable on the inside. I'm going to choose to distribute because I want to get rid of my fraction. And I still have our main bubble. So then I have 2 times negative 5/2, and I have 2 times 3. All of that's being cubed, and I'm adding 4. Now I get to cancel out my 2's top and bottom. So I have negative 5 plus 6 cubed plus 4. This is 1 cubed plus 4, which means I have 1 plus 4, which is 5. This is my output, which is y. And what was my input? 2 and 1/2. Notice how this is becoming a little bit more difficult than simply translating and creating your change this way. All right, let's go ahead and do one other equation, one function, excuse me. And then we'll move on to our other video, which is how to write an equation from a given graph. Let's see here. I'm trying to think of a good example for you. One with a, oh, let's do this one. I think I can do it. And we're just going to make this up and then see how it goes. So let's do h of x is equal to -2 times, oh, let's do this one. I got a good one, you guys, because I want to show you how you can undo this. Let's do 3 x minus 5, making this up, cubed minus, oh, I don't know, 4. Okay, so that's our equation. That is, I keep calling it an equation. That is our function. Okay, that is our function. So you can do what we originally did, which is here, figure it out, and then have our horizontal, have our vertical. However, what you can do is, you're in integrated math 3, and we can simplify this. This is not in its simplest form. So I'm going to do -2, here's my big bubble, times 3 cubed times x minus 5 cubed. Again, we can only do this because 3 and x minus 5 bubble are multiplying. So these two things are being multiplied. Again, only you can do the 3, the exponent like this, if it's being multiplied. And then we have our -4. So that means I get to simplify this. 3 times 3 is 9. 9 times 3 is 27. Oh, it's going to be big numbers. That's okay. Now we have 27 times x minus 5 cubed minus 4. Now this right here, this whole statement, the way you read it is -2 times 27 times x minus 5 cubed minus 4. So notice that all 3 terms here are being multiplied, so I get to multiply this together. So 27 times 2 is 54, and we do have a negative, so I have -54 times x minus 5 cubed minus 4, and that's what we have here. So you can do this here, or you can do this. It's going to end up with the same points for you. So this one does have a horizontal compression. This one does not have a horizontal compression. You have accounted for the horizontal compression by doing it into the vertical. So let's go ahead and do some points. Let's graph this. So let's start out with the original. -2 times 3 x minus 5. All of that's cubed minus 4. Let's translate this. I have a negative, so that means I have a reflection across the x-axis. I have a 2, which means I have a vertical stretch. I have a 3, which means I have a horizontal compression. I have a -5, which means I go right 5. And I have a -4, which means I go down 4. You should already know your reference points. Negative, let's do 1, 0, 1, 0, -1, 1, 0, -1. Those are your reference points. Then you have your horizontal and you have your vertical. Here's the thing, you guys. Whenever you reflect across the x-axis, yes, you are seeing the word x-axis. However, when you reflect across the x-axis, it's actually a vertical change. So be careful. It's always vertical change. Vertical. All right, so let's go ahead and create our new point. So here's my x, here's my y. So what's happening? Okay, so for horizontal, we have, what do we have? Horizontal, we have a horizontal compression. I see a 3. 3 is inside the bubble. We're doing what's the opposite. So the opposite of 3 is 1/3. Then I have a horizontal jump. So I see a -5, that means I'm going to do a +5. Do the opposite if it's inside the bubble. Let me change that because that looks weird. Okay, so I've done that one, Now what do I have? I have vertical reflection. So I'm multiplying this by -1. And I have a vertical stretch. So that means it is 2. You can kind of group them together, but just know this is a reflection across the x-axis. And then I see a down 4, which is a -4. So that is my equation. Here's my 1/3 plus 5 minus 2. And I'm just writing my equations the way that I usually do. And make sure they line up, because right now mine kind of don't, but I'm going to make sure to keep track of what it is. Type in your reference points. So I have 1, 0, 1. I have 1, 0, 1. And what do we have? What do we have? So I have 1/3 plus 5, that's 5 and 1/3. I have 1/3 times 0 plus 5, that's just 5. And then I have, oh, this one should be negative. And this one should be negative. So I have 1/3 minus 1 times -1 plus 5. So that means I have 4 and 2/3. Let's do our y's. -2 times 1 is -2. 4, 5, 6. That's -6. This one's -4. And this one is -2. Now, so far, this one's giving me a little bit of anxiety, but don't worry. Okay, don't worry. It's okay. We'll figure this one out together. So let's see how to graph this. What do we want? These are all positives. 1, 2, 3, 4. 1, 2, 3, 4. And we have -6. So 1, 2, 3, 4, 5, 6. Let's do 7 for good measure. Okay, so what do I have? I have 5 and 1/3, and I have a -6. So 1, 2, 3, 4, 5. 5 and 1/3, and -6. That's here-ish. Then I have 5 and -4. 1, 2, 3, 4, 5. -4. That's here-ish. And then what do I have? I have 4 and 2/3. 1, 2, 3, 4. 2/3 is about here, and -2. Pretty close together. So again, what's our vertex? Our vertex is H, K, or the middle button here, the middle one. From the middle one, ooh, be careful. This is where the reflection comes to play. Okay, let's talk about parent function. So parent function looks like this. If we reflect it across the x-axis, this point, this -1 and 1, and this 1 and 1, they flip. So now I have here, and I have one here. So my reflection across the x-axis now is a decreasing function, so it has to go down. Our original parent function is increasing as x approaches infinity, y approaches infinity. As x approaches -infinity, y approaches -infinity. However, when you do a reflection, as x approaches infinity, y approaches -infinity, it goes down. So because we did a reflection across the x-axis, as x gets bigger, your y needs to go smaller, and as x goes smaller, y needs to go bigger. Now again, this doesn't need to be exact, we're just doing an approximation. Change color so you can see better. So something like that. Now I don't recommend doing all of the points, just do the points that you need. Again, 3 points is what you need. So let's figure out what happened here. Let's see, maybe our math is wrong. Let's figure it out. So what I have is h of x is equal to -54 times x minus 5 cubed minus 4. So straight up, let's do vertex. Vertex is h, k, so let's see. If I plug in 5 in here, so I'm going to choose the pretty points, that method. I'm going to choose to put 5 as x. Why? Because 5 minus 5 And 5 minus 5 is 0. 0 cubed is 0. 54 times 0 is 0. And I get an output of negative 4. So 5, 1, 2, 3, 4, 5, and negative 4. So far, so good. Things are still lining up. My vertex is what it should be. So the other things are these 2 points. Let's see if those 2 points will match. Now, I don't want to do a fraction. If I do a fraction in here, I'm going to end up with something being divided by 54. And that's kind of what we want. But let's say I don't want a fraction. And I'm going to choose 1. No, I don't. I'm going to choose 4. Because if I choose input of 4, 4 minus 1, why do I keep saying 4 minus 1? 4 minus 5 is a negative 1. Negative 1 cubed is negative 1. So now I have negative 1 times negative 54, which is positive 54, minus 4, I get 50. Notice how bad it jumped? That's okay. And then I'm going to do 1 below, 1 above, so I'm going to do 6. 6, that gives me 1, positive 1 cubed. So I have negative 54 minus 4, which is negative 58. So, okay, here's my 3 reference points. Excuse me. My vertex is the same. However, this is why you don't have to label the stuff that you don't know precisely. Because now I have 1, 2, 3, 4 going all the way up to 50. That's pretty off the page. So let's say it's around here. Bear with me. And then you have 6, which is negative 58, which is 6 is here. Negative 58 is, hold on, 1, 2, 3, 4, 5, 6. Negative 58 is all the way down below the page. So we're talking about something crazy, crazy, crazy big. Still have our bend here, and we go down. And we're looking something like this. So the graph is the same, okay? The graph is the same. However, your reference points does change. But the graph is the same. They're just finding 2 other points on that graph. So you can choose to do that. Again, I made this example up. So if we were to give you one like this, it would be much smaller numbers, something that you can actually graph. But I do recommend doing either this method here, which is translating and writing your 2 equations and then plugging in your pretty points, your reference points, or choosing your pretty points as to what is going to simplify your bubble to get you the most simplest thing. You want 1, you want 0, and you want negative 1 in here. So another way that you can figure that out, here's a thinking bubble. So let's say you want 1, 0, negative 1. So let's do x minus 5 cubed. Let's not do that. I just want the bubble to equal to 0. I want the bubble to equal to negative 1, and I want the bubble to equal to 1. So you would solve each one to solve for x, and then you would use those x as your pretty numbers or pretty points. All right, beautiful people, this has been the end of the example video. Again, sorry for making that mistake earlier. I hope you caught it before I did. Enjoy the rest of your day, and I will see you in the next video where we are going to write the equations of graphs.